Good day, guys. Welcome back to the King Tutorial class, and welcome back to another series of differentiation in calculus. In our last class, we looked at differentiation using first principle, under which are some steps which we now solve questions under it, and I believe we are good to go with that. Now, in this class, we're looking at function of function or chain rule. Okay, so we see how we're going to be able to apply function of function to solve questions in what? In differentiation. Now, example 1. Given that y is equals to x minus 1 whole squared, find the differential of x with respect to y. Now, in this case, function of function or chain rule has a particular formula, which is what? The y dx equals to what? The y du times what? Du dx, where u is a random variable that is being used. Okay, that means you can use any letter of your alphabet. So, but in this case, okay, and in this series, we're going to be using what? The y dx equals to what? The y du times what? Du dx to solve. Now, example 1. Given that y is equals to x minus 1 whole squared, find the differential of what? Y with respect to what? With respect to x. Now, in which case, how I want to solve this is by saying what? Let u be equals to what? X minus 1. Now, but before you solve questions in function of function, you need to have basic ideas about how to differentiate normally. Okay. Now, in our last class or in our last series, we looked at a particular example, which is what? Y equals to what? X squared. Now, how can I differentiate this without using first principle? Now, we have a particular formula, okay, under differentiation that we can use, okay, which the first one is what? Given that y is equals to x raised power n, where your n represents the number of what? Of parts, okay. Given that y is equals to what? X raised power n, in that case, the y dx is going to be what? N times x raised power what? N minus 1. That's n here times this base, which is x raised power what? Subtract 1 from what? From the power, which becomes what? Nx raised power what? N minus 1. Now, that is for a question that whose coefficient is what? 1. Okay, because we have an invisible 1 here in the question. Okay, so for a coefficient which is more than 1, something like y is equals to ax raised power n, we're going to have the y dx. Dx is what? Na. I mean, that becomes n times a. Okay? N times ax raised power what? N minus 1. Which becomes what? Nax raised power what? N minus 1. So, that means now solve this. Becomes what? The y dx equals what? 2 times what? X raised power what? 2 minus 1. Which leaves us with what? 2x raised power what? 2 minus 1. Okay? Which is what? 2x raised power 1. Which is what? 2x. So, coming back. Having basic idea of how to differentiate normally, then we can now go on to what? To solve questions under what? Function of chain rule. In which case, we've made our u to be equals to what? X minus 1. That's the first step you have to apply here. You are under chain rule or function of function. Let u be equals to what? X minus 1 that is inside the what? Inside the bracket. Next thing you have to do is to what? Differentiate u with respect to x. Okay? Now, while we're differentiating u, that becomes du dx. While we're differentiating u with respect to x, because we have u and x, okay, basically functioning in the question. So differentiating u with respect to x becomes what? In this question, we have this as what? To be same as what? X raised power what? 1, okay, minus 1 x raised power what? 0, okay, where invariably x raised power 0 is 1 times 1 is what? 1. Okay, so I just want the function of x to be in this question so I can what? Differentiate very well. Now, in which case, du dx now becomes what? 1 times x raised power what? 1 minus 1 for this one, minus 0 times x, or 0 times 1x, whichever, raised power 0 minus what? Minus 1. Now, du dx in that case gives us with what? 1 times what? X raised power what? 0 minus 0 times what? X raised power what? Minus 1. Therefore, du dx is equals to what? Is equals to 1 minus 0, which is what? 1. So the differential of what? X is what? Is 1. Now, the first thing we did was to what? Make it to be equals to what's inside this bracket. Then we now said what? We have to find the differential of what? U with respect to what? With x. Now, since u is equals to this, it implies that what? Y from the question is going to be equals to what? U squared. Okay, since u is equals to that, it implies that what y is equals to what u squared. So differentiating y with respect to u in this case now becomes what the y du equals to, how we did it again earlier, becomes what 2 times u raised power what 2 minus what 1, which gives us what 2u raised power what 1, which leaves us with what 2u. Now from the formula, I said the formula is what for the function of different or chain rule is what y dx equals to what the y du times what the u dx times the u dx, which the y dx, okay, is equals to what the y du here is what 2u, u dx here is what 1, which becomes what 2u. Therefore, the y dx is equals to what 2 times, what's our u in the question? U is equals to what x minus 1. So the y dx for y equals x minus 1 squared is equals to what 2 into bracket what x minus 1. Example 2. Given that y is equals to 3 into bracket what 2x plus 1 all squared, we have to find what the differential the y dx. Now in this case, to solve this, I want to follow the same steps. The first time we followed in example 1 was to what make u to be equals to what the value inside the what inside the bracket, which is 2x plus 1 in this case. Now after that, we differentiate u with respect to what x. That becomes the u dx. Now note, x has a power 1 here in this question. So differentiating becomes what 1 times what 2x raised power what 1 minus 1 plus what. This is as though 1x raised power 0 as we solved earlier. Okay? So that becomes what 1 times what, that becomes what 0 times what x raised power what 0 minus what 1. Okay, now du dx is equals to what 1 times 2x raised power what 0 plus what 0 times what x raised power what minus 1, leaving our du dx to be equals to what 1 plus 0, which is what 1. So just note, differentiating a constant will give you 0. But differentiating a variable whose power is 1 will give you what 1 times the constant. So let's say differentiating x now. In that case, I'm going to get as what 1 times 1, okay, which is 1. But differentiating 2x is going to be what 1 times 2, which is what 2. Okay, so we made a mistake here. This is supposed to be 2. Therefore, our answer here is what is 2. So the next thing I have to do is what? Since we said u is equals to what 2x plus 1, it implies that what y will be equals to what? Or will be what 3u raised to what 2. Okay, so now differentiating y with respect to u becomes what the y du equals, that becomes what 2 times what 3u raised to what 2 minus 1, which becomes what 6u raised to what 1. Okay, which is what 6u. Now applying the formula of what function of function, the y dx equals to what the y du times what the u dx implies that what the y du is what the y du is what 6u times the u dx is what 2. Okay, which leaves out the y dx to be what 12u, and our u in the question is what 2x plus 1. That becomes what 2x plus 1. So that's how to solve what question using what function of function or chain rule. Thanks for watching that series. In our next video or in our next series, we'll be looking at how to use what product rule and quotient rule to solve questions in differentiation. If you've not subscribed to my YouTube channel, please do to subscribe and put on your notification button, so you can see new updates as regards our video. Thank you.